Okay, so this is a series of videos to take you through the Algebra 1A exam review packet for the 2015-2016 school year. Here we go. Jack wants to put a fence around his property. He knows the perimeter of the fence is given by the formula P equals 2L plus 2W. Solve this formula for W. So if we're solving for W, here's W, we need to move everything away from the W using PEMDAS backwards. So the first thing we want to do is subtract 2L. And we get P minus 2L equals 2W. Now we're going to divide everything by 2, because after we add or subtract, we're going to look for anything to multiply or divide away from the variable. And we've got our answer is W equals P minus 2L all over 2. Okay, number 2. Gino knows the formula for converting from degrees Celsius to degrees Fahrenheit is F equals 9/5 C plus 32. Which of the following is correctly solved for C? Once again, we're going to do PEMDAS backwards. If we're solving for C, we look for something to add or subtract away from the variable. So the first thing I'm going to do is I'm going to just rewrite this. F equals 9/5 C plus. So I'm going to subtract the 32. F and 32 are not like terms, so it just becomes F minus 32 equals 9/5 C. Well, now I want to get rid of the 9/5 that's in front of the C, and you would say it's a coefficient, you should divide it, but what we're really going to do is multiply by the reciprocal. So we're going to multiply by 5/9 on both sides. These cancel off. And I don't see my answer in the answer choices. So what I'm going to do is I'm going to distribute the 5, because I see that it's probably not B, because that's just 5. So it's like 9/5, so watch what I'm going to do. Okay, and then I'm going to distribute the 5, and it becomes 5F minus 160 over 9 equals C, and the answer is C. Number 3. Solve each equation, then select the appropriate choice from the 3 choices below and fill in that space for that circle for that choice only. So I see I have variable terms and I have constant terms. Let's take a look. Here we have a constant term, and here we have another constant term. I need to get them together. Here we have variable terms, and here we have more variable terms, and we need to get them together. I also notice that I have variable terms on this side and variable terms on this side, and they can be added. So maybe I'll just start by adding those variable terms. 4x plus 2x becomes 6x plus 18 equals, and now 5x plus x becomes 6x plus 18. And immediately I notice that both of these are identical. I have the same thing here that I have here. So even if I went and moved things around, like let's say I went and I was like, okay, well, let's put the variables on the left, and I'll subtract 6x. Let's put the constants on the right. I'll move this 18 to join this 18. Look what happens. I get 0 equals 0. 0 equals 0 is an always true statement. So I say the equation is always true because 0 always equals 0. So let's take a look at number 4. The first thing we're going to do for number 4 is we're going to distribute. So we're going to distribute the 5 to the x and the 5 to the 2. So that gives us 5x minus 10 equals 6x plus 20. So again, I've got variable term, Constant term, constant term. Now, I like the way that this is a 5 is over here. He's kind of smaller than the 6, so maybe over here, this is where I'm going to put my variables. So I'm going to subtract the 5x, and that gives me negative 10 equals 1x plus 20. Now I'm going to go move my constant term over. I'm going to subtract 20. And that's going to give me negative 30 equals 1x. I could divide by 1. I don't really have to, but I know that negative 30 equals x. And this one is a. There's only one solution, and it is x equals negative 30. Okay, let's take a look at number 5. Okay, number 5 is another same situation, and again, I need to distribute. So I'm going to distribute the 9 in number 5. And that gives me 9x minus 27 equals 9x plus 15. And immediately I see something interesting is going to happen because I've got this 9x and I have another 9x. So when I go to get the variable terms together, watch what happens. Switch to red. We'll subtract this 9x. And we end up with negative 27 equals 15 because the variables cancel out. Okay, well guess what? Negative 27 does not equal 15. So I say this equation is never true because negative 27 does not equal 15. Okay. Number 6. A food truck sells 3 items, hot dogs, sodas, and fries. In order to make a spreadsheet, the food truck owner needs to define some variables. And we have a list of his variables. Write an inequality for the following statement. The number of hot dogs sold in a day was at least 400. All right, so the number of hot dogs is H. And is sold in a day was at least, tells me it's greater than because it could be more than. So at least greater than or equal to 400. The next question says, what does the inequality S times P sub S is greater than or equal to 1,000 mean? Well, the first thing I'm going to notice is that S and P sub S, S is the number of sodas sold in a day, times the number of, or the price charged for one soda. So if I take the number of sodas in a day sold times the price per each soda, what that's going to give me is the money made from soda. So I'm going to say they made at least $1,000 from soda. That's kind of messy, sorry. Letter C says, write an expression for the total number of hot dogs, sodas, and orders of fries sold in a day. So the total number of hot dogs is H. The total number of sodas is S. And the total number of fries is F. So that's all I need to do. It's an expression, not an equation or an inequality, so it doesn't equal anything. It says, write an expression for the average number of sodas sold per customer in a day. So I need to know that the number of sodas is S. The total number of customers is C. If I take the number of sodas sold in a day and divide it by how many customers we have, I'll find out about how many sodas each customer purchased. So the answer is going to be S over C. S divided by C. On a recent day, less than $2,000 was made selling hot dogs and fries. Write an inequality for this statement. Well, the first thing I'm going to do is say less than $2,000. Okay. Now, to sell hot dogs, I have the number of hot dogs times the price for hot dogs. And that'll give me the total amount of money made on hot dogs. Then I'm going to add to that the number of French fries I sold times the price charged for French fries. So that means that hot dogs times the price of hot dogs, this gives me all the money made from hot dogs. Fries times the price of each fry gives me all the money made from fries. Added together is less than $2,000. Another day, the food truck sold a total of 1,500 hot dogs, fries, and sodas. There were 900 hot dogs sold. The number of sodas was 3 times the number of the orders of fries. Determine how many fries were sold. Well, the first thing I know is that if I sold 700 hot dogs, that means 1,500 minus 700 is going to be 800. So I know that 800 is the amount of fries and sodas that were sold. So I'm going to write 800 equals F plus S. Again, I got the 800 by taking the total amount and just subtracting the 700. Now, I also know that the number of sodas was 3 times the number of order of fries. So off to the side, I'm going to write sodas equals 3 times the number of fries. Then what I'm going to do is I'm going to take 3F and I'm going to replace soda with 3F because I know that the number of sodas equals 3 times the number of fries. And now my equation is 800 equals F plus 3F. And so now F plus 3F becomes 4F. And I can divide both sides by 4. And I find out 800 divided by 4 is 200 fries were sold.